Hello, my name is Neil Bassi, and the topic of my presentation is cardiovascular disease prediction. Points to discuss in this presentation are defining problem statement, data summary, EDA, feature engineering, then we will apply different ML algorithms, then we will compare different ML models, and then we will conclude the presentation. So first we will define the problem statement. Cardiovascular diseases are very common today due to poor lifestyle and unhealthy eating habits. So it will be very crucial if we can predict the risk of the cardiovascular diseases and help in the treatment. In this problem, we are provided the dataset from an ongoing cardiovascular study on residents of the town of Framingham. The classification goal is to predict whether the patient has a 10-year risk of future coronary heart disease. The dataset provides the patient's information. So basically, the problem is a classification problem to classify whether a patient has a cardiovascular disease or not. And the given data set is from an ongoing cardiovascular study on residents of the town of Framingham that contains all of these features, which consists of ID of the resident, sex of the patient, age of the patient, whether the patient is smoking or not. If smoking, then how many cigarettes per day, whether patient is on BP medications or not, then prevalent stroke, prevalent hypertension, diabetes, total cholesterol, systolic BP, diastolic BP, BMI, heart rate, glucose, and the dependent variable, which is 10-year CST, which represents the 10-year risk of coronary heart disease. All of these features are numerical and all of these features are categorical. Then we have performed the EDA. First, we have plotted the graph of the dependent variable, and we see that out of 3,390 given patient records, almost 500 patients had cardiovascular disease. And as we can see from the graph that the given data set is quite unbalanced, as the number of patients in each class are quite different. So we will perform some balancing techniques like undersampling or oversampling techniques to balance the data set. Out of 87 diabetic patients, 35 patients had cardiovascular diseases. As we can see in the graph, total number of patients who have diabetes were 87, and out of which only 35 patients had cardiovascular disease. Out of 100 patients on BP medications, 34 had cardiovascular disease. Out of 22 hypertensive patients, 10 had cardiovascular disease. Now we have analyzed the given data set on different age groups. First, we have analyzed the senior age group that consists of more than 60 years age of people. And we see that these people are at higher risk of cardiovascular disease, as the number of people who had cardiovascular disease were high in this age group. Then the adult age group, which is more than 32 and less than 47, are at lower risk of cardiovascular disease. As we can see from the graph that the positive bar is quite low. Then middle-aged adults that consist of more than 47 and less than 60 years of age are at moderate risk of cardiovascular disease. Thus, therefore, the increasing age is risk for cardiovascular disease increases. Then we have calculated the collinearity between different features of the dataset. And most of the given variables don't have any strong correlation as the values are not very high. Diabetes and systolic BP are somewhat moderately correlated. We can see here like that the value is 0.78. Systolic BP is also moderately correlated with prevalent hypertensive, that is prevalent hypertension. As we can see here, the value is 0.7. Glucose level are also moderately correlated to whether patient is diabetic. We can see here that the value is 0.62. Now we have calculated the correlation with the target feature. And we see that the none of the feature is quite strongly correlated with the target feature, as the maximum value is around 0.23 or 24. None of the independent variables are very strongly correlated with dependent variable. After that, we have performed the feature engineering. Feature engineering is the process of selecting, manipulating, and transforming initial variables into features that can be used in model training. Steps we have performed on our dataset are labeling the categorical features, handling null values, selecting features, and then finally transforming features. First, we'll see the handling null values. Null values are present in our dataset. Here are the total number of null values for each feature. We cannot apply ML model while null values are present. So we have to remove them using a simple imputer. To remove null values from categorical features, we have imputed null values with mode of that feature or the most frequent value. And to remove null values from the numerical features, we have imputed null values with the median of that feature. After that, we have selected the important features by using these two techniques. First is chi-square test, which is for categorical feature. Chi-square test is used for categorical features in a dataset. We calculate chi-square between each feature and the target and select the desired number of features with the best chi-square scores. It determines if the association between two categorical variables of the sample would reflect their real association in the population. And then the second method is multi-collinearity, which is for numerical features. We have calculated the correlation between every numerical feature and removed the one having high collinearity with any of other numerical feature. After that, we have prepared data for modeling. That is, we have split the data into train and testing dataset for model training. Since we have seen earlier that our dataset was quite imbalanced, so we have applied a SMOT technique on the trained dataset. And after applying SMOT, we can see that our trained dataset is balanced. Then we have applied different ML algorithms. Since we have to predict whether there is a risk of 10-year risk of future coronary heart disease or not, therefore it is a classification problem. And we have applied different classification algorithms, such as random forest classifier, logistic regression, SVM, gradient boosting, and KNN model. To apply ML algorithm, these three steps are followed. First, we will prepare data for model, which we have already did. Then we will train the model and perform hyperparameter tuning. After that, we will evaluate model on the test data. Now, during model training and validation, for different models, we have calculated these values for the different metrics for both train and test dataset. And we can see that all of our models are overfitting, as the values for the trained dataset is quite high compared to the test dataset in all of the metrics. Like here in random forest, the trained recall is 1 and test recall is 0.25, and train accuracy is 1 and test accuracy is 0.79. Hence our all models are overfitting. Also, we see that the logistic regression is performing quite better than all of the models, as the F1 score for the test dataset is 0.33, which is not quite high, but comparatively high than the other models. So the observation is all of our models are overfitting, as accuracy for trained dataset is high and low for test dataset. Accuracy is comparatively high for each model compared to F1 score of each model due to unbalanced nature of data. Logistic regression performed comparatively better than all other models due to higher test F1 score. Then we will use random forest model and logistic regression model for the hyperparameter tuning. We have performed hyperparameter tuning along with random search CV. And after performing hyperparameter tuning, the optimal parameters that we got for both models are these. And evaluating the model with the hyperparameter tuning, we see that the performance has improved a little bit, but not quite significantly. The F1 score for the random forest is now 0.29, which is earlier was 0.27. And for logistic regression, it is 0.35. And our models are not overfitting as much as they were before. We have evaluated our models, the one with hyperparameter tuning, on different threshold values also. And we can see that as our threshold value increases, the value of recall decreases and the precision increases slightly, and the F1 score increases slightly and then decreases. This is for random forest. And then for logistic regression, the graph is quite similar, but the F1 score reaches at least 0.35, which is maximum for all of the models. Therefore, lower threshold causes high recall, which is preferred for a disease prediction model. Conclusion: without hyperparameter tuning, all of the models are overfitting. F1 score didn't improve much after using hyperparameter tuning. Reason for this: no specific relation between features. Logistic regression performs comparatively better than other. Lower threshold is preferred as it results in high recall. Thank you.